Good afternoon, everybody. Wow, I would wish to be there with you, but I pulled myself together, some adrenaline, and here I am. But don't worry, I'm just physically here. All the rest is there with you. So I want to give you a very short presentation about our role in the project, meaning Work Package 4. And in Work Package 4, actually, we have two tasks. One is the risk management, and that Hamutal will present later. And the other one is the data analysis, which I'll try to present now. So actually, the task includes all the action support, whatever we can provide you regarding analysis of any data that you have, any source in any level. And I want to really give you the broad life cycle support in this analysis, utilizing all the possible tools that you have. And I know each one of you has got his own statistician, his own tools, and this is just an added value, another insight to what you can do. But any data, small or big, that you can provide, I would be very happy to analyze and to do it the best way I can. Speaking about big data, we are speaking about genetic data, proteomic data, and any other data that you have. But more importantly is a small data, where you have a small number of repetition with many, many parameters of the data. In this case, it's much harder to analyze, and we have got special tools to do that. And actually, what we want to do in each level, experimental level, as I said, clinical trials and so on, we want to give you the best support we can with an additional insight. And how do we do it? Actually, the idea is to converge all tools and all technologies, part that you already have in-house, the other one that we can provide as added value. And the idea is really to identify the relevant features, to reveal the underlying rules, and actually to provide a very reliable prediction. So this is the idea, and as I said, in each level, even if you have preliminary data, even if you have partially, just send it to me and we'll do the best of it. So the idea is to utilize all possible tools, all possible insight, and provide the best possible broad picture of what we have, this one that will enable reliable prediction. So as I said, we will utilize any scale of mathematical analysis, logic analysis, and our data mining tool, patented tool that I present very shortly. So what is really our added value in this project? And one of the tools that we can provide as added value is a data mining tool, which is specially designed to fill medical and biological needs. So what does it mean specially tailored for that? It means that it can handle both big data, as I said, proteomics, genetic, imaging data, and so on, but also small sets of data, which is usually in clinical trials or preliminary experiment and so on. How could we do it? Because we are less sensitive to overfitting, and the reason we are less sensitive is that we are combining logic theory and association approach with real statistical and mathematical and analytical tools. Another thing that we can analyze simultaneously combined data, numeric characteristic, meaning physical data, genetic data, proteomic data, imaging data, analyzing at the same time. More than that, we don't manipulate the data. So we can handle missing values. We can handle the data as is, meaning that we are not doing any normalization. We are not doing any ignoring of partial data and so on. So that will give us the real data as is, which is so crucial these days when the criticism about experimental repetition, about significance level is so high. So this is a very special tool that I'm willing to share with you and to utilize for your data. But what will we gain? We'll gain revealing the underlying rules. We are proven to reveal all if-then rule, and an optimal set of if and only if. Necessary and sufficient tools, which are a very strong tool. When you have the phenomena, you have these rules. When you have these rules, you are in some level of confidence level, have the phenomena. So this is very strong rules that we can provide. More than that, and not less important, we can provide the unexpected rules and unexpected cases. Those that sometimes could be very devastating, especially in clinical trials. So each rule is provided with a confidence level and thus enables prediction. And that's actually what we want to do. So I urge you to send me any toxicological or other data, and I promise a prompt reply, 24-hour reply. That's my promise. So just to give you one of the examples, since as I asked, nobody sent me any toxicological data, unfortunately. So I took an example that I have, which is from neurodegenerative disease, actually trying to reveal the main features, the underlying rules in Alzheimer's disease. And the reason I chose this example is that, first of all, if you can see at the first row, it's known. So once I'm analyzing the data, when the known rules came up, it feels good. It feels that you are on a reliable ground. And then you can see the small groups, which are not less important, providing different rules, and sometimes small, very special groups that are crucial in these clinical trials and other analyses. The other reason I choose this example, which is not very good, as you can see, we can predict only 71% of the Alzheimer's disease, because you can see here an example of both proteomic or protein expression and fat parameters. So this is very, very important, and I want to just, so you have a feeling of the features we can come up with. Another example, and I'm doing it very, very short. I'm here for any telephone call, any mail, any, we can do any Skype session that I can explain much more, and more than that, analyze your data. So this is another example of dialysis patients that we took from a database, those that have a protein administration. And the question that was asked here is whether those patients, what is their survival life? The dialysis patient that have the protein administration. Is it 1 year, 3 years, 5 years, and so on? And what are the underlying rules for this survival? So here I just presented it in a slightly different way, but the same point of view, the same parameter. Here you can see more physical parameters, and then what I said, we can combine physical parameters and imaging and proteins and genetics and so on. But anyway, what I wanted to show here that in this case, we took part of the data to study 400 out of 500 that were chosen randomly, and the rest 100 were used for prediction. And you can see here that the prediction went very well. It's 8 misses and 5 false alarms. So this is a very quick, slight impression to give you what we can provide. Another thing which could be a very strong added value from our side is the false discovery rate. It's one of the most quoted statistical papers or methods in clinical trials, and actually it was developed here in Tel Aviv University by Professor Yoav Binyamini, and the whole idea is really to increase the power or to decrease the power of false discovery rate. And actually we are building a threshold that you can utilize very nicely for clinical trials. And what we are doing these days is combining our tool with the fast discovery rate for clinical trials. And that's for you. So just to summarize, and I hope I was short enough, is that we are here for you, for anything you might need in experimental design, in analysis of any set of data, even preliminary, even small, whatever you need, any toxicological analysis you need, and also to embed the FDR for the clinical trials. And the rest regarding the risk assessment and management will be presented by Hamutal. So thank you very much. Good luck with the meeting. I'm there with you. Thank you.